What is four-quadrant system? Four-quadrant system is if the horizontal and vertical plane of projection are assumed to extend beyond the line of interaction, the four quadrants are formed, which are designed as first, second, third and fourth quadrant. So let us draw the quadrant system first. Let us draw, this is your vertical plane and this is your horizontal plane. So the notation of is VP and HP. If I will place a point A above the HP and in front of VP, then this will be your first quadrant or first angle. If I will place a point above HP and behind VP, suppose this point B is above HP and behind VP, then this will be your second quadrant or second angle. Suppose your point C is below HP and behind VP, then this will be your third quadrant or third angle. If I will place a point D below HP and in front of VP, then this will be your fourth quadrant or fourth angle. So this is the pictorial view of the quadrant system and this will be the orthographic view of the quadrant system. So this is the first angle, second angle, third angle and fourth angle. So these angles are formed if this quadrant system is rotate anti-clockwise. So this will be your first quadrant, second quadrant, third quadrant and fourth quadrant. So in first quadrant or first angle, again I will draw this quadrant system. Suppose I will place a point A. I will use the notation A for the point and small a dash for the front view and the notation A used for the top view. Or object. So if the observer is looking at this point from this side, right hand side, when the observer will look at this point, its projection will fall somewhat on this vertical plane. So the front view will fall somewhat on this vertical plane and the notation used is for front view is A dash. If the observer will looking this object from the top view, then its projection will fall somewhat on this horizontal plane. Then the top view I will use the notation A. And this is the reference line. This is the reference line. XY line is the reference line. So if I will reproduce the line on the reference line, I will, where both the lines are meet at a point on the reference line, I will use the notation here A node or A0. So this is the pictorial view. In this case, the vertical plane will remain fixed and the horizontal plane will move through an angle of 90 degree. This means this will rotate through an angle of 90 degree and this will rotate upside at an angle 90 degree. So both the plane will come in line with the VP. So when both the plane will come in line with VP, this means this point will lie somewhat on this plane. So this point A will come to the vertical plane, somewhat on the vertical plane. So this means this is the pictorial view. Again I will draw the orthographic view. So this is your reference line. How far this is your point A from this reference line, I will directly place the object from the reference line. Suppose this is how far, this is the distance from the reference line is at point at a distance X and the top view is at a distance point at a distance of Y. So this is the orthographic view when your object is lying in the first angle. So in second angle, again I will draw the quadrant system. Suppose a point B is lying above the HP and behind the VP. So when the observer will be on the same side, and this is your plane VP. So the observer is lying on the right hand side, and in this case the vertical plane is transparent. When this observer will look at this point, its projection will fall somewhat on this vertical plane. So this will be the B dash is the front view of the vertical projection. This is the reference line, and when the observer, for top view, the observer will looking at this point from the top side, its projection will fall somewhat on this horizontal plane. Again, so this point B is the top view of the point B. So again, if I will reproduce these two lines on the reference line, so this will be the point of B node. So again, the horizontal plane only will rotate through an angle of 90 degree, and your vertical plane will remain fixed through 90 degree right in clockwise direction. So this point will lie somewhat on when both plane will overlap each other, and this point will lie somewhat on this vertical plane. So both the point will lie above the reference line. So top view and front view both lie in the same direction on the same side and above the reference line. Now in orthographic view, this will be your B dash will be the front view and top view. This means both the front view and top view will lie on the above the reference line, and this is the point B node. Now again in third angle, let us draw quadrant system first. So this is the quadrant system, and this is your point C in the third quadrant, and the observer will lie again on the right hand side. When he will see this object point, its projection will fall on the vertical plane, and this will be the front view. And when he will see this object point from the top view, its projection will lie somewhat on this horizontal plane, and this will be your reference line. Again, if I will reproduce both the line, this will be your C node. So these 2 points meet at a point that is called C node. Again, this horizontal plane only rotate through an angle of 90 degree. This will come downside. This will come downside, and this will go upside. So both the plane overlap each other, and this point will lie somewhat on the vertical plane. So this is your top view. C will lie somewhat on the vertical plane. This means horizontal plane go upside and vertical plane on the lower side of this reference line. So in orthographic view, this will be your reference line, and this point C is the top view lie above the reference line, and the front view lie below the reference line, C dash. So this C dash, the third angle will just opposite to the first angle. So this is the main difference between the first angle and in third angle. And in fourth angle, again let us draw the quadrant system. In fourth angle, suppose I have this point D, which is lying below the horizontal plane and in front of the vertical plane, and the observer will lie on this right hand side, on the same side. When the observer will looking at this point, its projection will fall somewhat on this vertical plane. So D dash is your front view, and if the observer will seeing this object from the top view, its projection will lie somewhat on the horizontal plane, point D. And again this will be your reference line. Again, if I will reproduce the line on this reference line where both the lines will meet at a point, this point will be D0 point or D0 point. So this is the pictorial view of the fourth angle. Again, the vertical plane will remain fixed and only horizontal plane will rotate through an angle of 90 degree in clockwise direction. Again, this point D will lie somewhat on the same side of the plane as on the vertical plane. So both the point will lie below this reference line. So again, I will draw this point on the orthographic view. So this is your point D note where both the line meet on the reference line, and this is the distance of the front view and top view. Both the point will lie on the same side below the reference line. So this is the orthographic view of the fourth angle.